Hi everyone, welcome back to Appa Public School online classes. This is Seema Kane, your maths mentor of grade 3. So already we have completed our lesson number 7, that is geometry lesson. So in this session we are going to revise the same topic starting with the solid shapes. So welcome back. So you are seeing the variety of designs with colors. Yes, these are the solid shapes. Yes. So here some solid shapes, that is rectangular prism, sphere, cone, cylinder, pyramid and cube. So these are the solid shapes. So already we have learned what are the properties does it have. So how is the cone, how many vertices are there, how many diagonals are there, all those things we have learned. So again we are revising the same thing. So first we will go with the surfaces. So already we have studied the surfaces, two types of surfaces, that is flat surface and one more is curved surface. Here I have taken two examples, that is cone and cylinder. So these both figures having both the surfaces, that is that is flat surface and curved surface. So what do you mean by curved surface? Yes, curved surface means it is in a circular form. Curved means it is a circular form. Flat means, yes, flat means it is a plain surface. There is no up and down. It should be flat, plain. So these two types of surfaces we have studied. See here it is a cone. Yes, cone is there. So it is having a two surfaces. One is a curved surface and one more is the flat surface. So you will celebrate the birthday now? Yes. You will wear the birthday cap? Yes, you will wear. So it is which shape it is? Yes, it is a cone shape. So it is having how many surfaces? Yes, two surfaces. One is curved surface, one is flat surface. Yes. One more example, that is cylinder. You may take your water bottle. Yes, your water bottle. Here that is also having a two types of surface. One is curved and one more is flat. So whatever the up and bottom is there, cap will be there, no? Cap and bottom will be there, no? That both indicates the flat surface. Whatever is there in the middle, no? That indicates the curved surface. So cone and cylinder both are having the curved and flat surfaces. Yes. Next, so now we'll study faces, edges and vertices. So already I have explained with the 3D shapes. So what is this? Yes, which shape it is? It is a cube. So cube. So using this we have studied what is the face, which one is the vertex and which one is the edges. So already I explained. So what do you mean by vertex? Yes. So vertex is indicated by the point. Point is indicated by the dot. So in figure, how will see the vertices? Yes, we'll see corner. So this corner indicates a vertex. So if so many vertices are there, it will in plural form we will call it as a vertices. If it is single, we will call as a vertex. If so many are there, it is in a plural form. We will call as a vertices. So how you can observe from the figure? It is a solid figure, yes. So it means each corner indicates the vertex. Here corners are there, no? Here and these all are. So these corners indicates the vertex. So whatever the line is joining, no? This is line, no? This line is joining from one corner to another corner. What does it mean? If the line is joining one vertex to another. So the line is joining from one vertex to another. This line is called as the edge. Yes, this line is called as the edge. After joining each vertex with the line, how will join? By using the line, we will join the vertex. After joining the each vertex, we can form a figure. So this is a figure now. Yes, it is a figure. So what we are seeing here, whatever we are seeing here, no, these all are the faces. Here this is also face. Here it is. Whatever you can see, these all are the faces. Yes. So this is cube. So remaining so many solid figures are there. Here some examples are there. That is cuboid, cylinder, pyramid, cone and sphere. So in cube, how many vertices are there? How many edges are there? And how many faces are there? See here. See the figure. Yes. See how many faces does it have? Count. 1, 2, 3, 4, 5 and 6. There are 6 faces. How many edges does it have? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many does it have edges? It has 12 edges. And how many corners does it have? See here. 1, 2, 3, 4. Here 4 corners and here 4 corners. Corners is nothing but the vertex. Corners is nothing but the vertex. So this is about the cube. Next is cuboid. Cuboid is having a 6 faces and 12 edges and 4 corners. Next is cylinder. Take your water bottle as an example and see how many faces you can see. Yes, there are 3 faces. Already I said in a cylinder, 3 faces and 2 curved sides and there is no corner. There is no corner. It means there is no vertex. Yes, so this is about the cylinder. So next is pyramid, cone and sphere. So sphere is having any vertex? Is there any corner in a sphere? You take the example as a ball. In your ball, is there any corner? Yes? No, it is a sphere. It is a curved surface. There is no vertex. It means there is no corners. And there is no edges. If the vertex will be there, we will join a line. Without vertex, how will you join a line? Yes? Is it possible? No, it is not possible. So it means there is no edges. Faces is there? Yes, it has a one face. Which face it is? Which type of face it is? It is a curved surface. Yes, it is a curved face. So next is, so we have learned what we mean by point, line and line segment. So point is represented with the dot. Point is represented with the dot. A point has no size or shape, just it is a position. Is there any point is having any length? No, it is a fixed point. It is a one dot. The point is represented with the dot, means there is no size and length. It is a fixed position. So this is about the point. Next is line. How will you draw a line? Yes. Is there any starting point, end point to that line? No. So we can extend to any length. We can move forward and we can move backward. See here, a line is a straight path of points that has no beginning or end. So no beginning or end means there is no starting point and there is no end point. We can extend forward and backward. There is no limitation. There is no limit length. We can extend to any length. Yes. The next is a line segment. So what do you mean by line segment? Yes, it is opposite of a line. It means it should have a definite length with the starting point and the end point. The line should have a starting point and end point. It means it have a definite length. It means we can measure the length of that line. So that we call as a line segment. So a line segment is a portion of a line that has two end points. So line segment is a part of a line. Line segment is a part of a line, but it has a definite length and it also has a starting and the end point. It means we can measure the length of a line. So this is about the line segment. So next is ray. So ray is not there in your textbook. For your kind information, I am explaining the ray. So ray is a portion of a line which has one end point and extended forever in one direction. What does it mean? It means that it has a starting point but there is no end point. We can move forward but we can't move backward. Why? Because we have a starting point. We have to start in one position and we can extend to any length. Yes, it has a starting point, but there is no end point. So what does it mean? Yes, it means it does not have any definite length. We can extend to any length, but the thing is it has a starting point. Yes. Can you identify the difference between line segment and ray? Yes. Line is there is no starting point and end point. Line segment is it has a starting and end point, and ray is having only starting point and there is no end point. So this is about point, line and line segment. So next, measuring a line segment. So I already explained how to measure the line segment. Yes, using a scale. So I already explained you have always while measuring the length you have to start from the 0. You have to start with the 0. Yes, while measuring you have to start with 0 and any number. You can take any number. So measuring the length using a line segment. So here some lines are there. See here. First we have to start with 0. After 0 we have a small line. Yes. Here small lines are there. Here big line is there again. Again small line. Again big line. Here after 10 lines it is 1. So here one more big line is there. It indicates 0.5. 0.5 means half centimeter. We will write as 0.5 centimeter. It means half centimeter. So 5 lines is there now here. Here after 0, 5 lines indicates the half centimeter. Again 5 lines are there. After 5 lines number 1 is there. It means 0 to 1 is 1 centimeter. Here 0 to after 5 lines it is a half centimeter or 0.5 centimeter. Always will write 0.5 centimeter or half centimeter. So after 0, 5 lines indicates a half. Again half. After that again 5 lines will be there. After that 5 lines 1. It indicates 0 to 1. There will be a 10 small lines. Yes. So this is about the how to measure the line segment. So here 10 lines, after 0 10 lines will be there. After one big line is there, that is 1. It means 0 to 1. It is a 1 centimeter. Here 1 to 2. It is 2. It is not 2 centimeter. It is again 1 centimeter. Why it is again 1 centimeter? Always while measuring we have to start with the 0. If we take 1 to 2, again it is 1 centimeter. If we have taken 0 to 2, it is 2 centimeter. Got the difference? Yes. So if you have taken 1 to 2, it is 1 centimeter. Or you have taken 0 to 2, it is 2 centimeter. Yes. It is the, have you got the difference? 0 to 2 and 1 to 2? Yes, very good. So move next. That is open and close figure. So already I explained what you mean by open figure. Yes, very good. Open figure means starting point is different and end point both are different. Starting and end point both are different. So close figure means starting and end point both are same. Starting and end point both are same. That type of figures we call as a closed figures. The starting point, end point both are different. So we call as a open figures. See here some examples. Here it is a one shape is there. Here it is. There are 3 examples are there. Here it is a starting point and it has moved with the different direction and it has end with the different place. It means starting point is here and end point is here. So this is an example of a open figure. Starting point and end point both are different. Starting in one point and ending with the another point. Here it is also starting with one point and ending with the another point. So these are the examples of a open figure. So next is closed figure. So here I have started and I have moved with a different direction and I have end with the same point. Yes, I have started here and I have end with the same point. So if the starting and end point both are same, this type of figures we call as a closed figures. What we call closed figures. Starting and end point both are same. Here star is there, here triangle is there, here square is there. It is different shape. So these are some shapes with the these are the examples of a closed figure. Yes. Move next. Symmetry. So what do you mean by symmetry? Yes. After dividing the things or object, we have to get the exactly two halves. It should be exactly two halves. So here see, here some objects are there, here some shapes. These are the mathematical shapes and these are the natural things, natural objects. The first one is apple, butterfly, this is heart shape, this is some insect, this is aroma, flower, home, aeroplane. These are some shapes, objects. Yes. See here I have drawn one line. Here. See the line? Dotted line is there now? Yes. What this indicates? The dotted line? This dotted line indicates the line of symmetry. What does it indicate? It indicates the line of symmetry. It is the vertical line of symmetry. If we divide the figure into two halves, after dividing the figure, we have to get the two exact halves. Means two similar objects. After dividing, we have to get the two similar objects. That we call as the symmetry, symmetrical object. See here, if you cut the apple, we'll get the two halves are same. So here butterfly, heart shape, this insect, this arrow mark and this butterfly, this home shape and this aeroplane. Divide it. After dividing, if we get the similar objects, that we call as a symmetrical object. What we call? We call as the symmetrical objects. Next is symmetrical shapes. These are some shapes. Yes, these are some shapes. This is circle. This is hexagonal, rectangle, triangle, square and this is heart shape. So again we have drawn here a vertical line of symmetry. So if we cut the figure, after cutting the figure we will get the two similar halves, two similar things we will get. Here also we will cut the figure, again we will get the two similar things. Here flower, you cut the flower, here half and here half. These half should be similar. This type of things we call as a symmetrical object or symmetrical shapes. Yes. Next, patterns. In patterns we have a tangram and tiling. So first we'll go with the tangram. So I already explained what you mean by tangram. Tangram is a classical Chinese game. It can be played with the shapes, with the pieces of shapes. It may be 5 or 7. You can multiply into 100 innovative designs. You multiply with 5 and 7, you can create a innovative designs. Here are some examples. Here it is shoe, here it is plane, shirt, this is tree, key, candle, rocket and house. See here, these are the shapes created with the shapes. These all are with the using a pieces of shapes. They have created a tangram. See, count how many shapes are there in shoe. 1, 2, 3, 4, 5, 6, 7. Using 7 pieces of shape, they have created a picture of shoe. Shoe. Yes. Next is plane. Again, they have used the shapes piece. That piece we call as the tans. Whatever here pieces they have joined, no, these pieces we call as the tans. This using tans, whatever they have created the shapes, no, that we call as the tangram. This is tangram. These pieces we call as a tan. It is a Chinese game. Using 5 and 7 shapes, they have to create a different type of innovative designs. Yes, this is a plain design. See, once we will count how many pieces are there in this. 1, 2, 3, 4, 5, 6, 7. Again they have used the 7 pieces of shapes. Using 7 pieces of shape, they have created a plain design. Yes. Next is shirt. Count how many are there? 1, 2, 3, 4, 5, 6, 7. Again they have used 7 pieces of shapes. 3, 1, 2, 3, 4, 5, 6, 7. So here whatever they have created the design, they have used only 7 pieces of shapes. Each shape they have created with only 7 shapes. So what are the shapes they have used here? It is a diamond shape, rectangle, triangle, triangle, triangle and triangle, triangle. Here so many triangles are there, only one square and diamond shape is there. Here it is. Here all they have used only triangles. In rocket they have used only triangles. Here they have used diamond and square, and here they have used only triangles. You may use any shape, square, rectangle, cube, cuboid, sphere. You can use any shape. With that you have to make a piece. With the paper, on paper you have to draw and cut the shapes, and you have to create a design. Different types of designs you have to create. But the thing is, you have to prepare the shapes. That pieces you have to prepare. You have to draw on the paper and cut it, and you have to paste, or you have to make a design. In a way to design, you have to create using the shapes. Yes. Next, patterns. In patterns, we have again is styling. First, we have gone with the patterns. In patterns, first we have learned symmetry, then tangram. Next is tiling. So after I explain what I mean by tiling. When a design is made using only one shape, that we call as a tiling. Tiling is possible when only it made up of a shape. It is only possible when it made up of a shape. Thus, it can be arranged without any gaps or overlaps. See here, some examples are there. Tiling. This is a basic shape. Square shape tiling is there. Square shape tiles we have arranged here. These are the arrangement of tiles. The basic shape of tile is square. This square shape of tiles we have arranged. Is there any gap or overlap here? No. The tiles are arranged without any gaps or overlap. So this is we call as a tiling. So arrangement of tiles we call as a tiling. So tiles can be arranged without any gaps or overlaps. Using one shape, we will create a tiling. So this is a square shape and this is a triangle shape. See here how they have arranged. One is upward face, one is downward, upward, downward, upward, downward. Like they have arranged the tiles. Yes, they have arranged the tiles now. One is upward, one is down, up, down, without any gaps or overlaps. They have arranged the tiles. So this is the arrangement of tiles. So these three are the examples of a tiling. You will see in your home. Yes, you can see in your home how they have arranged the different types of tiles. Yes. Thank you.